Hi, in this video we're going to talk about how to solve proportion application problems. Okay, so we're going to talk about different kind of word problems that can be solved using a proportion. The first step that we're going to have to do in every one of these problems is we're going to actually draw a proportion box, and I'm going to show you what that looks like. Then we're going to label the terms that are being compared, and then we're going to fill in the proportion box as much as we can. And the only part of the proportion box that we have left blank, we are going to solve it by either using a scale factor or by using the cross product. Those are the two ways that I showed you yesterday on yesterday's video, the regular proportions, how we work with proportions. So let's start off here on problem number 1. Okay, let me clear my screen here. Let me scoot this up a little bit. All right. So the first problem says Karen is purchasing invitations for a party. She can purchase 15 invitations for $3. How much will it cost Karen to purchase 60 invitations? The first step is to draw a proportion box. And a proportion box looks like this. I'm going to draw it here on the side. It's a square, kind of. And you're going to split it into 4 equal parts. That's your proportion box, okay? Then we're going to label the terms that are being compared. So let me highlight the two things that we're comparing, the two units. In this case, we're talking about 15 invitations. So invitations is one thing. And the other thing that's being compared here is money. So for $3, right? And then we want to know how much. That's talking about money, how much. And how much money will it cost for Karen to purchase 60 invitations. So the two things that are being compared over and over is invitations and money, right? Okay, so we're going to write down the two things. We're going to label the two terms that are being compared. Here we go. First of all, let me choose a kind of like a dark green color here. Let's see, let's make it a little darker. That one should be good. Okay, so invitations. I'm going to write the word INV for invitations right here. And I'm going to do the same thing on this side, invitations. Because invitations and invitations have to go together. Okay, so therefore, money and money, I'm going to put it on the bottom. It doesn't matter where you put the money or the money, as long as you keep it consistent. So if you're going to put the invitations on the top on this side of the proportion box, then you need to put the invitations again on the top on this side of the proportion box. That way you can get your information organized. Okay, now that we have labeled all the terms that are being compared, now we're going to fill in the proportion box. So now let's talk about this first invitations. These invitations right here, whoops, wrong color. This is green. So the invitations that we're talking about here is these 15 invitations. That 15 is going to go right here on the first side. Okay. And then the $3 that goes with those 15 invitations, because that's how much they cost, these $3 are going to go right underneath the 15, because these two quantities go together. 15 invitation costs $3, right? So they go together. On the other side, the other information that we know is we have 60 invitations. Well, because we have the invitations on the top of the left side, we're going to also have invitations on the top on the right side. So I'm going to put the 60 right here. And then it says how much. How much is talking about money, right? So that means that we're going to have to fill in the amount of money we want. And since we don't know how much money that is, I'm just going to put an X for just any variable, any letter that we're missing. We're missing a number here. And whatever that number is, that's going to be my letter X. You can put the letter P or the letter Q or the letter R, whatever letter you want to put. If you want to M for money, actually let's do that. Let's change that X to an M because we're talking about money. That makes a little bit more sense. So M for money, right? Alright, so now that we have filled in the proportion box, we're going to solve it by either using a scale factor or cross multiplying, doing a cross products. Okay, in this case, do you know of a way that I can use a scale factor? Is there a number that I can multiply 15 by to give me a 60? 15 times 2 would give me 30. Oh, well, I'm looking for 60. So what about 15 times 4? Okay, let's try that. 15 times 4. Let's just come over here to the side and work that out, see if it works. 4 times 5 is 20, carry the 2. 4 times 1 is 4, plus 2 is 60. Yeah, that gives me 60. So if I multiply this 15 times 4, and actually I'm not going to write that inside the proportion box. I'm going to write it on the top, times 4. If I multiply 15 times 4, I'm going to get this 60 right here, right? So if I do it on the top, I'm also going to have to do it on the bottom. So I'm going to multiply this 3 times 4 as well. So 3, not 15, that's 3. 3 times 4 is going to give me the value for that m that I'm looking for. And 3 times 4 is 12, right? So therefore m has to be 12. And that's it. That's how you solve the proportion problem. Okay, so make sure that you use the proportion box. Make sure that you label the proportion box. Then you fill in your numbers. Then if you have this little number right here that is called the scale factor, remember how we abbreviate that, SF, for scale factor. That's the number that you multiply by to get to the other number. If you can find that number, then you're done. You don't have to cross multiply and divide. All you have to do is multiply by that number on the top and multiply by the same number on the bottom. So in this case, m is 12. So we're talking about $12. So to answer the word problem, to finish this problem, it says how much will it cost Karen to purchase 60 invitations? The answer would be, it would cost Karen $12 to purchase 60 invitations. Okay, and this is going to be your final answer because this is your complete sentence. Okay, so that's it. Now let's talk about number 2. Alright, Anthony can swim 50 meters in 40 seconds. If Anthony's rate remains constant, how many seconds will it take Anthony to swim 200 meters? Okay, so let's first draw a proportion box, and this time see if I can use one of my shapes here. I'm going to use a black proportion box. So here's my, whoa, that's too thick. Let's make that a little bit less thick. How about this one? Yeah, that looks better. So there's my proportion box, and I'm going to split that up into that one and this one. I think it took me longer to do this kind of proportion box, right, than the regular hand-drawn. That's okay though. Here we go. Looks a little bit more neat. As long as you guys can see my nice work, that's all that matters. Okay, so now let's talk about the two things that are being compared. The first thing that we come up to is 50 meters. So that's one of the things that we need to highlight or underline or circle. Meters is one thing. The other thing that we're talking about in this case is seconds. So those are the two quantities that are going to label my proportion box. And if we look at the next one here, the next one that we have, that 200, that's meters. And the question is how many seconds. We don't know how many seconds it's going to be. So that's going to be the other red one. So meters and seconds. So that's the two labels that are going to go in my proportion box. I'm going to put M for meters here on the top. So I'm going to put M for meters here on the top as well. And seconds, I'm going to put S for seconds. And S for seconds. Or actually I'm going to write down SEC for seconds. And I'm actually going to write MIN for minutes. Okay. That way I know what those letters mean. Okay, so now let's fill in. Now that we have labeled our proportion box, now we actually fill in the proportion box. So we have 50 meters. So that's going to be here where the 50 goes. And that takes 40 seconds, right? It takes him to swim 50 meters, 40 seconds. So that 40 is going to go where the seconds go, right here. And remember, these two things go together because they give me together here in the problem. Then the next thing says how many seconds. We don't know how many seconds. So that's going to be an S maybe for seconds. So I'm going to put an S here for seconds. And I do know there's 200 meters. So I'm going to put 200. Oh, I put meters and I put minutes down here. That might be something that's not very good. So This time I caught it. You guys didn't have to tell me in class. Mr. Burgano, you messed up on number 2. I can almost hear you guys. Alright. Well, that's good. That means you guys are paying attention. So now we have meters and we have meters. Okay. So 50 meters in 40 seconds and 200 meters in I don't know how many seconds. In S seconds. Again, we're going to look for the scale factor first. Is there a number I can multiply 50 by to get 200? Hopefully you said yes, because 5 times 4 is 20, right? So 550 times 4 would be 200. So the scale factor here is going to be times 4 again. That's my scale factor. So 50 times 4, that's going to give me that 200. So that's what I have to do here in the bottom as well. I have to multiply that 40 times 4. 4 times 4 is going to give me 16. And you have a 0 behind it, so it's 160. So my question is, or my answer is 160 seconds. That's how long it's going to take Anthony to swim 200 meters. So that's my answer. It takes Anthony 160 seconds to swim 200 meters. There. Now this 160 seconds, couldn't we change that to minutes maybe? Because that would make more sense. 160 seconds is kind of hard to think about. But you know that there's 60 seconds in 1 minute, right? So if I take away 60 seconds from 160, that's going to leave me with 100 minutes. 100 seconds. So this 60 seconds right here, that equals 1 minute that I just took out. And I'm left with 100 seconds. If I take away another 60 seconds, that's going to be another minute that I take off. So 100 minus 60, that gives me 40, right? So I took out 2 minutes, 2 full minutes, and I'm left with 40 seconds. So really, this 160 seconds could be replaced with, it takes Anthony 2 minutes and 40 seconds. That's really what that means. Okay, so you can leave it as 160 seconds for this problem, but if you are working on the STAR test, and the STAR test, the answer choices that they give you, it talks about minutes and seconds. This is how you figure out how many seconds that actually is, how many minutes and seconds this many seconds really is. So make sure you just take away 60 seconds, that equals 1 minute, and then whatever's left, if you cannot take another 60 out, full 60, then that's how many seconds you have remaining. Okay, so that's it. Now let's talk about number 3. Ryan is making pancakes for his family. The recipe calls for 2 cups of pancake mix for every 1 cup of milk. How many cups of milk would Ryan need for 6 cups of mix? Okay, so I'm gonna help you set this one up, and I don't think you're gonna need my help to finish this one. So, but I am gonna help you set it up, because I'm just that kind of a nice guy. So here we go. Alright, so there's my proportion box. That's the first step, remember that. And cut that in half. Cut this in half. Okay, so there's my proportion box. Now, after you label your proportion box, you have to label it with the correct units, with the correct 2 things that are being compared. Okay, in this case, it says the recipe calls for 2 cups. So that's the first thing that we need to see, cups of pancake mix for every 1 cup of milk. So we can't say cups and cups. We're gonna have to say cups of pancake mix for 1 cup of milk. In this case, they're both the same, cup and cup. So you have to tell them apart by saying what kind of cups they are. Here the question says how many cups of milk, and that's the blue color that I used. How many cups of milk will Ryan need for 6 cups of mix? Okay, or the pancake mix. So that's the other red right there. So the 2 things being compared here is cups of mix and cups of milk. So we have to be careful how we label this. I'm going to put milk right here on top. So that means that I'm going to put milk right here. Well, there it is. There's the word milk right there. Let's see. So milk goes right here on the top as well. And then we're going to put the word mix down here and the word mix down here. So now let's fill in our numbers. We know that we have 1 cup of milk for 2 cups of pancake mix. Okay, and then over here we have we don't know how many cups of milk, so let's call that I don't know, K for milk, because I was going to say C for cups, but they're both cups. And then I was going to say M for milk, but M starts with milk, and then milk starts with M and mix starts with M too. So the only difference here is like that X or maybe that K. So as we're looking for K for milk, I'm going to call it K. So here's going to be K. I don't know what that letter is going to be. K amount of cups. And mix, that means 6 cups of mix. So I'm going to put the 6 cups of mix right there. Okay, so now you can look for your scale factor, and if you can find it, you can finish this. I'm going to leave this one alone and see if you can finish it on yourself by yourself. Number 4. On the map of Texas, 1 inch is equivalent to 50 miles. How many miles will Jerry drive if the distance of the map measures 4.2 inches? Okay, so again, let's identify the two things that are being compared. Before we do that, we have to draw a proportion box. So let's go ahead and draw a proportion box. Okay, there it is. Now let's identify the two things being labeled. 1 inch is equivalent to 50 miles. So that's the two things that are being compared, inches and miles. Then the question says how many miles. We don't know how many miles Jerry will drive if the actual distance on the map is 4.2 inches. So inches and inches and miles and miles. That's what I'm looking at here. So that's what I'm going to label in my problem. I'm going to put inches on the top, so I'm going to put inches on the top. Then I'm going to put miles on the bottom. Then I'm going to put miles on the bottom. Now I'm going to fill in my numbers. 1 inch, there's my 1 inch, is 50 miles. So I'll put 50 right here. How many miles? I don't know the number of miles. I'm going to put M for miles. Will he actually drive if it's 4.2 inches? So the 4.2 goes right here. Now in this case, it's really easy to see the scale factor because 1 times a number has to give me 4.2. The only way that I can get a 4.2 is if I multiply by 4.2. So that's my scale factor. So you can multiply 1 times 4.2 gives you 4.2, right? So all you have to do here is multiply that 50 times 4.2, and then you get your M, how many miles that's going to be. So you can finish that. Now let's talk about the blueprint. And let me see if I can leave that picture of the house right there. The blueprint shows, the blueprint below, or not really below, but beside it right here, shows that 1 centimeter on the model will represent 2.5 meters in real life. How wide will the house be if the model is 7 centimeters wide? Okay, and this is kind of like an architect plan, because I don't know if I told you this, but I used to work for an engineer, and we used to get the architect plans in big old pieces of paper, and they would have a picture like this, and we would have to draw. We would have to look at it, and we would have to draw the sidewalks, and we would have to draw where the cars would park, and do a lot of different things. And I'll show you one of those plans throughout the year so you can see what I'm talking about. But this is very, very common. This here is called the legend of the map. Another word for legend is key. You can call it legend or you can call it the key. And this tells you how to read this map. And this is not really a map, it's just really a picture. But it tells you that every one of these centimeters from here to here, you can see the little squares. That distance, 1 centimeter, that represents actually 2.5 meters in real life, in a real house. Okay, so if you have 7 centimeters, how wide is it going to be in real life? So we're going to solve this with a proportion because we're comparing two different things. So here's my box for the proportion. Okay, and I'm going to identify my two things that are being compared. Here it says that 1 centimeter is equal to 2.5 meters. So the two things are being compared, centimeters and meters. So now I'm going to identify the next thing. How wide will the house be if the model is 7 centimeters? So centimeters are in blue. And when it says how wide, that's talking in real life, right? That's talking in meters. So I'm going to call that M. Or you can call it W for width. If it says how wide, up to you. Doesn't really matter again what letter you use, as long as you label your proportion correctly, your proportion box. So here I have centimeters and meters. Well, I'm going to abbreviate centimeters with a cm. So I'm going to put those on the top, and I'm going to put the meters down here on the bottom. Now those are red. So I'm going to go ahead and keep those consistent, being red. Okay, so now I'm going to fill in my numbers. 1 centimeter is the same thing as 2.5 meters. That's what they tell me right here in this legend. If you can see that. 1 centimeter is 2.5 meters. So that's what I'm going to put. 1 centimeter is 2.5 meters. Now the next thing says I have 7 centimeters. So the 7 goes here with the centimeters. And they want to know how wide it actually is. So here's the M or the W or whatever letter you want to use. Okay. Here's another easy one that you can use with the scale factor. Scale factor, all you got to do is multiply 1 times 7, right, to get the 7. So to get this M, all you got to do is multiply 2.5 times 7. And then you get your M. But on this one, I'm going to actually work it out for you in the cross multiplication way. And I want you to do it the same way, because I want you to see how that works. The last 3 problems we worked have been with scale factor. I want to show you at least this one with cross products. So what we're going to do here is we're going to cross multiply. Okay, and we're going to cross multiply. Let's see, I haven't used green. The 2.5 times the 7. 2.5 times 7, let's see what that's going to give me. 7 times 5 is 35, carry the 3. 2 times 7 is 14, plus 3 is going to give me 17. And I have 1 decimal place right here in my problem, so I'm going to put a bubble and put a 1 underneath, inside the bubble. And I don't have any here, so I'm going to put a bubble and put a 0 inside that bubble. So when I add those 2 bubbles together, 1 plus 0, it's a total of just 1. 1 decimal place in my answer. So my decimal needs to be right here. So I end up with 17.5. So I'm going to write that right here, 17.5. And that's going to be when I multiply 7 times 2.5. Now when I multiply the other side, the other diagonal, 1 times m, well, any number times any letter is just going to give me that number times that letter. So in order for me to get rid of this 1, all I have to do is divide it by 1, right? So 1 divided by 1, they cancel each other out. And 7.5 divided by 1 is just 7.5. And this is not a very good example on this cross product. But that really is how you do it. Cross multiply and then you get your answer. So it's the same way as you will get the same answer as if you found your scale factor. But there it is. M equals 7.5. So to answer this question, how wide will the house be? The answer would be the house will be 7.5. And the M stood for meters, right? So 7.5 meters wide. That's how wide it would be. And there's my answer in complete sentence. Okay. Alright, flip the page. Okay, here we have some application problems like the ones you're going to see on the STAR test. It says a 24,000 gallon pool is being filled at a rate of 40 gallons per minute. At this rate, how many minutes will it take for this pool to be 3/4 full? Uh-oh. Alright, this is gonna a doozy, but we can tackle this one. We can use proportions and we can use everything that we've learned so far. So here we go. 24,000 gallons. That's the first thing I can see. So the first units that I'm looking for is gallons, right? Over here, I have gallons again, 40 gallons. But then it says per minute. And we've talked about in class about that word per. We talked about that whenever we talked about unit rates. Okay, and unit rates means that you have per minute. That means for every 1 minute. So that's what that means. 1 minute. Okay, now I'm actually going to highlight it in orange as well. So you know that those two mean the same thing. Per minute, that means 40 gallons in 1 minute. 200,000 or 200, not 200, 24,000 gallons and here is 40 gallons. So those are my two quantities in gallons. Here I have 1 minute, and the question is how many minutes. So I need to know exactly that. That's my other minutes. I don't know how many minutes it will be. Okay, but I'm not talking about the full tank of the full pool. I just want to fill it up to 3/4 of the way. So before I start doing my calculations, I need to find out what 3/4 of 24,000 is. And the only way that I can do that is if I pay attention to what's happening here. I want to know what 3/4 of 24,000 gallons is, right? Now you guys remember this keyword I told you in class? Of, that means to multiply. So we're going to have to actually going to multiply these two numbers, and we're going to get the answer for how many gallons is going to be 3/4 of 24,000 gallons. So the only way I can do this, since 24,000 is a whole number, I need to put a 1 under the whole number, right, to make it an improper fraction. So then I go ahead and multiply. I'll do this one with you. 4 times 1 is 4. Yeah, that one's easy. But now what about the big one, right? All right, 24,000 times 3. 3 times 0 is 0. 3 times 0 is 0. 3 times 0 is 0. 3 times 4 is 12. Carry the 1. 3 times 2 is 6. Plus 1 is 7. So it's 72,000. That's the number that goes on top. Now this means divide, right? 72,000 over 4. So in order for us to change this to an improper fraction, to a mixed number or a whole number, we need to divide, top in, bottom out. So here's going to be my division. 72,000, that's the top number, so that goes inside. The bottom number goes outside. 4 goes into 7 one time, that's 4. Remainder 3. Bring down the 2. 4 goes into 32, I believe it's 8 times. 4 times 8 is exactly 32, that's remainder 0. When I bring down the next 0, 4 can't go into 0, so I'm going to put a 0 there. When I bring down the next 0, I still have 0, so 4 goes into 0 0 times. And finally the last 0, that's the same thing. 4 can't go into 0, so I'll put a 0 on top of that. So when I actually think about what 3/4 of 24,000 is, my number is going to be 18,000 gallons. So that's the number that I want to replace. Instead of using that 24,000 gallons for my proportion box, I'm going to have to use this 18,000 because we're looking for only 3/4 of the pool, not the full pool. If it would have been the whole pool, then I can use the 24,000. But here we go. Let's go ahead and fill in the proportion box. Here's my proportion box. And I'm going to label it with my two things that are being compared. In this case, we have gallons. So I'm going to put gallons on the top. And I have minutes. Okay, so now the gallons. There's 40 gallons, so I'm going to put 40 gallons. And that says per minute, per 1 minute. So that means I'm going to put a 1 minute right here. The other amount of gallons that we have is 18,000. So I'm going to put 18,000 right here. And I don't know how many minutes it's going to be. So I'll put a T for time in this case. I don't know. You can put any letter you want. But now here's the question. Is there a scale factor that would multiply 40 times a number and gives me this 18,000? Well, there could be, but the easy way to do this would be the other way around, to cross multiply. Okay, so I'm going to cross multiply. And when I cross multiply, I'm going to end up with 18,000 times 1. I multiply the top times the bottom diagonally. So 18,000 times 1 is just going to give me 18,000. Any number times itself, any number times 1, it's itself, the same number. So now I'm going to do the other cross product, 40 times t. And if you remember what I told you a little bit ago, when you multiply a number times a letter, you just get the same number and the same letter. That means they're multiplied. So now I need to get rid of this 40. You remember what happened with this 40 and this t right here? We multiplied them, right? So this means that they're multiplying right now, 40 times t. The only way I can cancel that 40 and leave t all by itself so that I know what that t is going to be, how many minutes, how much time it's going to take, I need to undo that multiplication. And to undo the multiplication, I have to do the opposite of multiplication, which you probably guessed it by now. it's division. So I have to divide. And the only way I can cancel that 40 is if I divide by the same number, by 40. 40 divided by 40 just gives me 1, right? That's why this 40 and this 40 cancel out. It just gives you that 1 in front of the t. But if you remember from the previous video, I told you about this 1. That's kind of like a ghost 1. It's implied. If I have just t, how many t's do you see? I only see 1 t, right? So that means that I have 1 t. This 1, it's there, but it's hiding. You really don't show it. It's just implied that there's a 1 right there. So 40 divided by 40 is just t. But if you're going to divide this side of the equal sign by 40, you also have to divide this side of the equal sign by 40. By the way, I don't know if you noticed when I put the equal sign there, but when you multiply the two cross products, you need to set them up equal to each other. Okay, so that's where that equal sign came from. Multiply 1 times 18,000, you get 18,000. Then you multiply 40 times t, and whatever you get, you're gonna put it equal to that first cross product. So anyways, there's the equal sign, there's the two sides. I ended up dividing by 40 so I can get rid of that 40. And if I do that to one side, I need to do it to the other side. So now I'm going to divide that 18,000 over here on the side by 40. Can 40 go into 1? No. Can 40 go into 18? No. But 40 can go into 180, right? I know 4 times 4 is 16, and this is 18, so it's probably going to be about 4. So I'm going to try 4. 4 times 0 is 0. 4 times 4 is 16. When I subtract, I get 0, 2, 0. Remainder 20. So we're in good shape. Because remember, the remainder cannot be bigger than the number you're dividing by the divisor. So I'm going to bring down the next 0 now. I have 200. And I know 40 goes into 200 5 times. Because 4 times 5 is 20. So 5 times 40, a 4 with a 0 behind it is 20 with a 0 behind it. And when I subtract, I get 0, 0, 0. Bring down the last 0, and 40 goes into 0, 0 times. So t is 450, and because t is talking about minutes, it's 450 minutes. Now it's the same kind of question as the other one, where, well, in this case actually it's a multiple choice answer, and all of your answer choices are in minutes. So we can go ahead and answer the answer choice. A would be the correct answer choice because that's the only one that's 450 minutes. Okay. Now, if the answer choices were in minutes and in hours, you would have to take away 60 minutes from 450. That would give you 1 hour, right? And then you can keep taking away 60 minutes at one time, and every time you take 60 minutes, you gotta keep a tally mark on how many hours that is, so that you can combine the hours and the minutes. All right, so that's number 1. Number 2 says a recipe for a dessert requires 4 cups of strawberries for 1.5 cups of yogurt used. At this rate, how much yogurt should be used if 2 cups of strawberries are used? And this is pretty straightforward once you draw your proportion box, because you have two things being compared. So first, let's draw a proportion box. And again, it doesn't have to be perfect, but make it big enough so where you can write inside of it, but not too big to where you don't have any room to work out your problem. So now let's identify the two things that are being compared. 3 cups of strawberries. You know what? Strawberries are red, right? Let's draw. Oops. I didn't want to clear the whole thing. Strawberries are red. So let's highlight that in red. 3 cups of strawberries for every 1.5 cups of yogurt. So we can highlight that in blue. So the yogurt is the blue and the strawberries is the red. The question says, at this rate, how much yogurt should be used if 2 cups of strawberries are used? So there's my strawberries again. And what I don't know is the yogurt. Okay, so now let's fill in the proportion box with the labels. Okay, strawberries. So I'm going to put S-T-R-A-W. I'll just put S-T-R-A-W for short. Strawberries. Here's going to be strawberries as well. On this side is going to be yogurt. And yogurt. Okay, so let's see. Let's fill in the numbers inside the proportion box. 3 cups of strawberries. There's my 3 for strawberries. for every 1.5 cups of yogurt. 1.5 is the same thing as 1.5, and I know that you're more comfortable with decimals than with fractions. So go ahead and put it as a decimal if you want to, okay? And now it says how much yogurt. We don't know how much yogurt that's going to be. So I'm going to put a Y for yogurt. And then it says 2 cups of strawberries. So there's my 2 cups. Now in this case, I don't see a scale factor. I cannot multiply 3 times a number and give me a 2. At least not one that I know at the top of my head. So I'm going to go ahead and cross multiply and use my cross products to solve this problem. So I'm going to multiply 1.5 times 2. Let's see what that gives me. 1.5 times 2. 2 times 5 is 10, carry the 1. 2 times 1 is 2, plus 1 that we carried is 3. And then we count the decimal places behind our decimal. We have 1 right there, and we have 0 right here. So 1 plus 0 is a total of 1 decimal place that needs to be in my answer. So it's 3.0. So when I multiply those two, I end up with 3. I could put the 3.0 if I want to. I don't need to, but I could. But I'm just going to leave it as 3 for right now. Now I'm going to multiply the other cross product. 3 times y. And remember, we're going to set these cross products equal to each other. Here's my equal sign right here. So 3 times y is going to give me just 3y. Because you just multiply 3 times y. So you get the same number and the same letter, 3y. Now, the point of this whole problem is to find out what y is, how much yogurt you're going to need for 2 strawberries. So that's why I want to get this y all by itself down here. I want to know what y is equal to. The only way I can do that is if I get rid of that 3. And the only way I can get rid of this 3, remember, we multiply 3 times y. So to get rid of multiplication, I have to do division. That's what this line right here means. I'm going to divide by 3. 3 divided by 3 is just 1, so those 3 cancel out. So I don't have to write the ghost one that goes right here. But then if I do this to this left, to this right side of the equal sign, I also have to do it to this side of the equal sign. And what's 3 divided by 3? Oh, it's the same thing. They cancel out. They give me a 1. Now, I cannot leave it as a ghost one over here because there's nothing here right now. So I have to put the 1. So that means that I have 1 yogurt. So if I have 2 cups of strawberries, I need 1 cup of yogurt. So the answer is A, 1 cup. Okay, so now the last thing that you have here is the problem number 3. And I'm going to let you do this one. At a concession stand, 6 hot dogs cost $6.72. At this rate, how much would 8 hot dogs cost in dollars and in cents? Good luck with this one. Make sure that you follow your steps, just like we did in every one of these problems that we worked today. Okay, so we'll see you tomorrow in class.